Hello, Luke here. I'm just going to finish up that on that last video. This is a very closely related to the last one we were working with, and I want to just show how we're going to get actual timestamps from this graph. So hopefully you were watching that last video and saw that, okay, we got this graph with all these plateaus saying where there's a song, and now we want to actually just turn that into real times in seconds. So just to kind of illustrate the problem, I'm going to iterate through our predictions list. And I'm going to do that with enumerate, so I get the index and I get individual predictions as we go. And if I just said, okay, if prediction is greater than 0.5, so 0.5 would be the middle of this graph. And so if I say, okay, if the prediction's, a spike that's above that, well then, let's say, well, we're going to try and create a list of times. So let's call it final times, because we already have a list called times. This is our final, or let's say that's called song times. That's a little more descriptive. And what we're going to say is song times dot append times I. So what we're saying is at any given moment, if the prediction's above 0.5, well then add that time at that moment. So that'll be at the same as we iterate through. It'll be where we can also iterate through the times list because they're the same length. And then when we're done, what we can say is just print song times. And sure enough, this is what we get. And this is kind of what I was alluding to last time or talking about, is that we get multiple times for each hermit thrush song. So here we got 302.3, 302.4, 302.5. You can see it's kind of iterating through and finding all these moments that are above, but these aren't all songs. Some of these are, all these ones at 313, there's 4 of them. Those are just one song. So we want to be a little smarter about this, and so we can kind of build this as we go. So what I'm going to say is, instead of just finding one, let's find, how about a plateau? I want to look for a plateau. And so I'm going to ask if the minimum of predictions, I'm going to grab a little slice of this, from I to I plus 3. So that'll be 3. If essentially it's saying if the minimum out of 3 in a row is greater than 0.5, then it counts. And essentially that's saying if there's 3 in a row that are above 0.5. That's really what it's the simplest way to say it. And so now I do that, and that's a little better. I pared it down, and it's better, but it's not perfect yet. We still see that there's a bunch at 318, and that's because we have a particularly long plateau at 318. So there's 3 in a row, and then there's 3 in a row, and then there's 3 in a row, because let's say there's 5 or 6 in a row at 318. Well, then you can see you can take multiple slices of 3 out of a group of 5, and that's a problem. But that's easily solvable. What I'm going to do is I'm just going to say when you find one. So when this becomes true, well, don't check the next one, because I know, well, a hermit thrushes never sing back to back. Like it's not going to start a song 0.1 seconds after it starts another song. It's not going to stutter, I guess, when it sings. And if it does, maybe that's a cool anomaly or something, but it's not what I'm studying, and I've never seen it happen in thousands of hermit thrush songs. So I think I can build this to say, okay, well, if you find one, wait a little bit before you search again. Don't start searching for one while we're still in the middle of this song that's being sung. So I'm just going to say, how about wait 0.5 seconds? And the way I'm going to do that is I'm going to create a wait variable, and I'm going to set it equal to I. So when we find a song, I set this wait variable to I, and maybe I'll initialize it at the beginning. And what I'm going to do is say, well, if this weight variable, or sorry, if I is greater than weight plus 5, and remember, this is, I'm not using decimals because we're talking about I, the index. And so it's going through, and it might be, say, at 23, and it finds a song. It sets weight to 23, and then it comes in and it'll be at 24. Well, is 24 greater than 23 plus 5? No. So it's not going to do the next part, if I tab that in. And then it'll go around again and say, okay, well, what about, I don't know, 25? Is 25 greater than 23 plus 5? No. And it'll keep iterating, and finally it'll get to 29, and it'll say, is 29 greater than 23 plus 5? And the answer is yes. And so now it'll start checking again. And then eventually it'll find a song again, and it'll update this weight variable. So that's just a nice little, simple little way to get it to kind of stop checking for a second. Or 0.5 seconds in this case. So if I run that, now I get 4 timestamps that correspond to these 4 plateaus. So that's a good thing. And what I want to do is I want to look at a section of the recording because this worked perfectly. This found 4 hermit thrush songs, and you can see 4 hermit thrush songs. It passed the smell test here, where it actually didn't get fooled by these other ones. You can see a little spike right here at 316, and then we can go up here and be like, okay, at 16 on here, well, that's corresponding to this other bird. So it almost got tricked, but it didn't get tricked enough that it created a nice big plateau. So we were able to use our post-processing knowledge to kind of go, well, where's our threshold for what counts and what doesn't? Because the model started to get tricked. And if we look at other sections, we're going to find that there's trickier sections. So I've already marked it here at 2310. We've got a section, and you can see this is messy. What we've got here is a bunch of noise on the recording. We've still got a hermit thrush singing here and here and here up higher and then here, but gosh, in between it we've got other birds having, this is kind of like that time when you're walking through the woods and all the birds are just chattering away. And you can see that this could be a little more difficult potentially. So I'm going to actually run this right now. And all I'm going to do is change this, our times, to 2330 and 2310. So I'm going to grab now 20 seconds worth around here and run the code again. And this will take a couple seconds again, just like it did last time. And in the meantime, I'll prepare this so that we're ready to, zoom in if we want to. And it's done. And now look at this. So now we've got many spikes. And these spikes are too many because this is the same region, remember. This is just 20 seconds here and it's 20 seconds here. But here I've only got 1, 2, 3, 4 hermit thrush songs and a whole bunch of other chatter. And sure enough, here we can look and we can see 1, 2, 3, and then 4. But this is like if we were just looking at this graph, we might think that there's 1, 2, 3, 4, 5, 6 hermit thrush songs. And so this is where the post-processing, in the way that we've designed things, this is where we can add a little bit of finesse or a little bit of trickery, hopefully, to actually improve it. Because I don't want all 6 of these. Like let's even see, if I run this, it grabs 5 of them. So one of these, I'm guessing this one didn't fulfill the 3 in a row that we set up. It's only maybe 2 in a row that are up there. So it got weeded out. And you can see we got 2310 and 2315, but we didn't get this 2313 or so. And so it got weeded out, thankfully. But this other one later on got kept in. So we might ask ourselves about that. And I'm actually going to just create another short video just to address that. So yeah, stay tuned.